Hey there, and welcome to All You Need to Know. I'm Tomas, and I created this channel where you can find fun, short, and insightful videos of some complicated topics. So sit back, relax, and let's dive in. Today we are going to cover some fundamentals about Ethereum with Evelyn, who will share with us all you need to know. Hi, Evelyn.
Hello, Tomas. Thanks for inviting me. It's a pleasure to be here.
Before we get into Ethereum, can you briefly explain to our audience what is blockchain and what are the most important characteristics of it?
Sure. Blockchain is a decentralized, distributed ledger technology that allows information to be stored and shared securely and transparently among a network of users. Some of the most important characteristics of blockchain technology include decentralization. There is no central authority or single point of control, as the blockchain is maintained by a network of users. Immutability. Once data is recorded on the blockchain, it cannot be altered or deleted, making it highly resistant to tampering and fraud. Transparency. All transactions on the blockchain are visible to all users, promoting transparency and accountability. Security. The use of cryptographic algorithms ensures that data on the blockchain is secure and protected from unauthorized access. Trustless. The trustless nature of blockchain allows parties to transact with each other without the need for intermediaries, reducing the costs and risks associated with traditional intermediaries.
I think our audience will understand better with a real example.
Of course. Let's say Alice wants to send some money to Bob. In a traditional financial system, this transaction would go through a bank or other intermediary who would verify and process the transaction. However, with blockchain technology, the transaction can be processed directly between Alice and Bob without the need for an intermediary.
Thanks, Evelyn. I think now the audiences have a better idea of what a blockchain is. Let's dive into our topic today, Ethereum. What makes it special compared to Bitcoin?
So just like Bitcoin, Ethereum is a kind of blockchain. But Ethereum brings an innovative concept called smart contracts, which are self-executing computer programs that can automate the execution of agreements between parties. While Bitcoin was primarily designed to serve as a peer-to-peer digital currency, Ethereum was designed as a platform for building decentralized applications, dApps, using smart contracts. Smart contracts allow developers to create a wide range of applications on top of the Ethereum blockchain, including decentralized exchanges, prediction markets, and other forms of decentralized finance. Overall, Ethereum is a powerful technology that allows people to create and run decentralized applications and execute smart contracts without the need for intermediaries. It has the potential to transform industries like finance, supply chain management, and more.
That's truly revolutionary, but how can the smart contracts be executed without the need for intermediaries? Who maintains the machine executing these smart contracts and who makes sure the programs are executed as expected?
Great question. In Ethereum, the smart contracts are executed by a network of computers called nodes, which are maintained by the users of the network. These nodes work together to validate transactions and execute the code in the smart contracts. When a smart contract is created, it is stored on the Ethereum blockchain and can be accessed and executed by anyone on the network. The code in the smart contract specifies the conditions for execution, and once those conditions are met, the contract is executed automatically by the network of nodes. Because the smart contract code is stored on the blockchain and is visible to everyone, it is transparent and tamper-proof. This means that the rules of the contract cannot be changed by any one person or entity, and everyone on the network can see that the contract has been executed correctly. This decentralized approach to executing smart contracts eliminates the need for intermediaries, as the rules and execution of the contract are automated and can be validated by anyone on the network.
Then this leads to another question: what's the incentive for people to maintain the machine running the smart contracts and validate the execution result?
In the case of Ethereum, nodes that validate transactions and execute smart contracts are incentivized to do so through a process called mining. In the early days of Ethereum, mining was done using a process called proof of work. In proof of work, Nodes compete to solve complex mathematical problems in order to validate transactions and add new blocks to the blockchain. The node that solves the problem first is rewarded with Ether, which serves as an incentive to keep validating transactions and executing smart contracts. However, mining using this approach requires a lot of computational power and energy, which can be costly and inefficient. Recently, Ethereum moved towards a different method of incentivization called proof of stake. In proof of stake, nodes are chosen to validate transactions and execute smart contracts based on the amount of Ether they hold and are willing to stake as collateral. Essentially, the more Ether a node stakes, the more likely they are to be chosen to validate transactions and receive a reward. This method is seen as more energy efficient and cost effective than proof of work, as it doesn't require the same level of computational power. Overall, the incentive for nodes to maintain the Ethereum network and execute smart contracts comes from the rewards they receive in the form of Ether.
Yeah, that makes sense. I would love to discuss more on the mechanism of proof of work and proof of stake. But I think we already unpacked lots of details this time. Maybe we can cover this in another episode. Thank you, Evelyn, for the insightful conversation.
Sure, it's my pleasure.
Hopefully, you all learned something about blockchain and Ethereum today. See you next time on All You Need to Know.